let's move on. Java and client-side load balancing. So Java right now in our case is doing what we call a client-side load balancing. So for that, it's using Ribbon. This is being this would be replaced in the future by what's called, I think, a Sprint Cloud Load Balancer. But the concept remains the same. In the case of like client-side load balancer, what happens is that Java as an application sends a request, which is this is just like a library inside the Java application. So sends a request to Ribbon. Ribbon basically has queries like the console to with a list of IP addresses, and then basically does request from from server 1 to server 2 or server 3, or maybe you just want to define the ribbon behavior that it always goes on to server 1. So ribbon basically does the client-side load balancing by basically having the list of all of these servers available to it, and then basically just sending the request to either of it, whatever it wants to. Any questions to this point? Another important thing to note is that okay, how does it keep this list updated? So, for example, this may be like dying, or maybe there is a server 4 that's coming up for that service. So, Ribbon has a long polling to console agent, so it's picking up on the changes that's happening. So, it always keeps the list updated. Okay, so in case of PHP and things like Go, we are what we are using is HAProxy and Consul template setup. In this, basically, it's a bit a little bit alike, but it's what's called typically a server-side load balancing. In this case, service A sends a request to. So we have an HAProxy running first on each of our EC2 instances, or container instances. So a request is then sent to the HAProxy. HAProxy basically has in its configuration list of all the downstreams for service B. So it would then just forward the request to service B. So how is this configuration created is that we have also another daemon running on each of our container instances, what's called a Consul template, which is long polling for the changes on console side. So it's polling for, okay, what are the containers going up and down on the cluster? And whenever there is a change, so whenever there is a container that is coming up or down in the cluster, it is recreating the HAProxy configurations and updating the IP and port information, adding new nodes, deleting a node, whatever is happening in the cluster. So when a request comes in, the HAProxy is ready to basically route the request to the correct place. Does it make sense? Yes. Okay. Cool. Okay. So I think we're also running out of time, but and there's a class account setup. So this I would leave for you to explore on your own behalf. So these slides will be shared. Essentially, this is not the part of ECS, but they are also very good to understand. Is how what kind of network accessibility we have from between our ECS clusters and to Elastic caches, to SNS and SQS. So go on and look at these on your own time. But what I want to touch briefly is IAM permissions. With IAM permissions, we have like three kind of roles that are involved. So first is the task role. This is what you are normally interested in. This is what defines what your containers would be allowed to talk with, for example, to S3 bucket, to a kinesis, to maybe triggering a Lambda, to an SNS and SQS queue. So this is a role that is attached to the task, and then from the task to the container. But there are also execution and instance roles. Execution roles allows the ECS agent, for example, to authorize with ECR and then pull the images on the instance that are basically required for running the task. So This is an implementation detail totally abstracted away from you, but this is also very important because this allows allows the ECS agent to, for example, pull the ECR images on your behalf. And finally, there are also like things like service link stores and instance stores. They allow us to talk, they facilitate the ECS and EC2 interaction, meaning that they allow the EC2 instance to do certain actions on the cluster level, on an EC2 instance level, and then ECS as a service, for example, maybe registering the task on a load balancer and stuff like that. So there are different kind of roles involved, and you're typically interested in the task role, but just so that you know there are other roles that are also need to be defined, and not typically in our setup at least they are restricted away from you. Okay, yeah. Set task execution rules allows you to define your task behavior, C permissions, dynamo permissions. Service link roles allows us to define a way to facilitate the ECS and EC2 interactions. On the topic of monitoring and logging, what we have is that in each of our container instances, we are running FileBeat as a daemon set. What this FileBeat is doing is that it's basically looking at all of the logs that your containers is producing, and then it's shipping onto the log stash where basically they get parsed and filtered and transformed, and then ingested into Elasticsearch. And then you can use Kibana to query your service logs so that you don't have to go into your container, attach into your containers and then look into those logs. So if you want to look into each of these logs, just do service.name colon followed by your service name, and then you would see all of your logs from all of your containers from in one place. You can filter them, you can build graphs on them, and yeah. Cool. So I guess we are a bit over time, but that's it.